Woohoo! Welcome back. Today we're going to be working on solving systems of equations, and this time with a method called substitution. Woohoo! Now you're going to notice a couple things. One, I used the word algebraic, which if you haven't said algebraic out loud yet today, you should say it, is a little treat for your mouth. Algebraic. And so this is an algebraic way to solve as opposed to the graphing method, which we did in the last video. So we're going to be looking for solutions to systems of equations. And for right now, we're going to stick with two equations. The other thing you're going to notice is that we've got this lovely little brace over here. Now, some books and settings use the brace to denote a system. These go together. Sometimes you won't get that, so don't assume, but I will use it since the book does use it. And the problem says to go ahead and solve and check. And rather than telling you what you're supposed to do, I thought I would show you. And of course, Matt Damon is here because he's very concerned, because in the last problem we left him stuck on Mars. Let's see if we can get him home today. So I've got two equations. They're both linear equations. And right off the bat, you'll see that they are written in funny forms. Neither one is written in y equals mx plus b or slope-intercept form. And that's okay. Notice that this one, the second equation, is written in terms of x. This is solved for x, right? So we've got an x equals. That is an excellent place to start if you're going to be using substitution. So the way substitution is going to work is in one of the equations, you want to solve for one of the variables, x or y. Does not matter which one you choose. And then you take the other equation. So I've got 3y plus x equals 4. And again, I'm going to refer to this as a. So this is our a equation. And what I'm going to do is in place of the x in the a equation, I'm going to put parentheses. So this is still basically the outsides of the a equation, but I'm going to take my b equation, and where it says that x equals 2y minus 1, I'm going to put that right in there, right where that x is. So right where the x is, instead of x, I'm going to write 2y minus 1. Now, why is it called substitution? Because I'm substituting, instead of the x, I'm substituting what x equals. So I've got that there. Now, this one's really nice because this one is already, it's given to you. It's almost mostly done at this point. So let's take a look at what this equation then becomes. So I've got 3y plus 2y minus 1 equals 4. And I notice that at this point, there's only one variable. Yay! Up here, two variables. And this is how this method works. We're going to substitute to get ourselves to the point where we've got just the one variable. So then we can combine like terms and basically be done. Basically. So 3y plus 2y is 5y minus 1 equals 4. Plus 1 plus 1. 5y equals 5. So y equals 1. Yay! And then the question is, are we done? And the answer is, Matt Damon isn't sure. So he's not sure whether we're in happy land or sad land. But let's think about what's happening. These two equations, each one represents a line. And if two lines are intersecting, there we go, two lines intersecting, the point of intersection should have a x-coordinate and a y-coordinate. This is just the y value. So what do we have to do? Well, so we start with the equation. We substitute one of the equations into the other equation, and then we solve. And then we have to use y equals 1 to go ahead and find x. I'm going to draw a little line there so that we can give ourselves some space for the check that's going to happen. So I have to find x. I can choose either of the equations. I'm going to go ahead and use x equals 2y minus 1. That equation is that's the b equation. So I'm using the b equation to find x. And let's see, y is 1, so x equals 2 times 1 minus 1. That's 2 minus 1, which equals 1. So y and x are both 1. So we have the answer 1, 1. So we do have happy Matt Damon. Yay! He gets to come home from Mars. Yay! Okay. But why is Matt Damon slightly sad? Well, Matt Damon is slightly sad or pensive because you do have to check. It is a good idea to check. It's not that hard to check. You've got two equations. Let's check them. So remember, again, we've got x equals 1 and y equals 1. So we got a single answer. That's that situation where we have that x, and we're at the point in the middle. So I'm going to check 3y plus x equals 4. So that would be 3 times 1 plus 1. Does that equal 4? That's 3 plus 1 equals 4. Yep, that one works. Okay, let's look at the second one. X equals 2y minus 1. So that's 1 equals question mark 2 times 1 minus 1. That's 2 minus 1. That's 1. Yep. Oops, you can't see where I'm writing. Sorry about that. 1 equals 2 times 1 minus 1. Is that true? That's 2 minus 1. That's 1. Yes! It checked. So that's going to be the process. The process again, solve one of the equations for one of the variables. Does not matter which one. And if you're given one, go ahead and use that. Substitute it in, solve, and check. And then we've got happy Matt Damon. Where's happy Matt Damon? Yay, happy Matt Damon. He gets to go home even though his fists are curling up. I'm not sure why. Yay. It seems that Matt Damon doesn't do so well with the humidity. Okay. So before I turn the page, I feel like it's important and to mention, and yes, there will be some sad Matt Damon sneaking into screen here because every now and again, students say, why do you do such easy problems in the videos? And why don't you do really hard ones? And the answer is it makes the videos really, really long. And everyone's like, no, we want to see the really hard ones. So, dun dun dun. You guys ready? Sad Matt Damon. Dun dun dun. This was just about the nastiest problem I could think of. It's not quite the nastiest, but it's pretty bad. Why is this problem so difficult? So let's talk about what this problem is. This is a simultaneous, that means at the same time, system of equations. I have two linear equations. One is in fraction land. One is in decimal land. Fractions and decimals do not generally get along. So we're going to have to rewrite each of the equations, and then we're going to have to see if there's an intersection point. Yay! I know. I'm very excited. I hope everyone is very excited. I hope this video isn't 400 minutes long, but we'll see. We can do it. We can do it. Courage! Matt Damon believes in you. I don't know if he does. I don't think he actually... I don't know. We can pretend. Matt Damon on a stick believes in you. Woohoo! And so does... It feels like we should bring in some more support animals. I've also got Blue Dinosaur here. Blue Dinosaur believes in us. Everybody believes in us. You guys ready? So, this is absolutely going to be a choose-your-own-adventure story. If you find a situation like this, you've got to decide what you're most comfortable doing. Personally, I want to convert each of these equations into an equation with just integers. So I want to get rid of the fractions and the decimals. Some of you might be saying, oh, but can't we just write these as decimals? And the answer is, ha ha ha, no. I actually wrote this on purpose because 2/9, not a nice decimal. Oh no. There we go. Oh, I know already. Syntax error. 2 divided by 9 is 0.22222. And you may also know that 2 divided by 3, 2 over 3, is 0.6666666. These are not nice fractions, so they will not convert to decimals. And if you round, if you use just 0.2 or 0.22, your answer will be incorrect. Okay, so you asked for complicated. There you go. Okay, so I'm going to, again, label this top one A, and I'm going to label the bottom one B. So first step, I'm going to clean up the equations. And at this step, you can do whatever you like. You can choose to clean them up however you like. I'm going to go ahead and clear fractions. So I see I've got 9, 9, and 3. So I'm going to pick an LCD of 9. And I'm going to multiply. So 9 over 1 times 2/9 x minus 9 over 1 times 2/9 y equals 9 over 1 times 2/3. Woohoo! And then I'm going to bring in my red pen of destiny. The 9's cancel completely in the first two terms, and then over on the right, almost completely. The 9 gets rid of the 3, and there's a 3 left over. So I get 2x minus 2y equals 3 times 2, 6. And then I realize, wait a minute, these are all divisible by 2, so I divide everybody by 2 because you're allowed to do that too. Anything you can do to a regular equation, you can do when you're solving a simultaneous system. Okay, pardon me, guys. X minus y equals 3. Personally, and I would think everybody watching this equation versus this equation, I think this one wins by all. Any way you can slice it, that's a better one. Okay, let's see what we can do to clean up the second equation. Pardon me, guys. Blue dinosaur, you can come over here. Okay, keep your support friends close. You do not have to clear, oh, I forgot to write, clear decimals. It's also clearing fractions, right? The decimals are basically just fractions with denominators like 10 or 100, so you can look at it the same way. You do not have to clear decimals. A lot of folks can use decimals and not have to worry about it, but I would still encourage it. So we're going to go ahead and clear the decimals. Each one of these has a single digit to the right of the decimal point, so I'm going to multiply by 10. So I get x equals 2 minus y. Nice. Now, one thing I've given to you, because I was worried that this video might become 400 minutes long, I did give you another situation where our simultaneous system, x minus y equals 3, this is the new version of A, and x equals 2 minus y, which is the new version of B, has an equation where you've already solved for x. Now, this doesn't always happen. It is possible that when you're doing these problems, you will have to solve for x or for y. And so there will be examples of that in the homework, and you can always talk to me about it. I also have to give full disclosure, I don't think substitution is the best method. I think given a chance or a choice, I would always use the next one we're going to talk about, which is going to be elimination or elimination by addition. Substitution is really useful in a very small number of times. And then the rest of the time, you should be using elimination or elimination by addition. So, but let's go ahead and finish this. I know, I'm just stalling. Okay, so this is the new system that we're going to be solving. Now, is it really new? No, I've just rewritten the old system. Is it exactly what the old system was? No, it also is not. So it is consistent. It'll have the same solution set, but it's not exactly the same one. So I'm going to take my A equation, x minus y equals 3, and in place of the x, so I'm going to write the whole first equation, but instead of the x, I'm going to write 2 minus y. Now, why is this helpful? Well, this is helpful because here I have 2 variables, and here I have 1 variable. So I've gotten rid of one of the variables, so it's going to be easier to solve. Okay, once I remove the parentheses, I get 2 minus y equals 3. Oh my goodness, this is just awesome, isn't it? So 2 minus 2y equals 3. I'm going to subtract 2 from both sides. I get negative 2y equals 1. And then negative 2y over negative 2 equals 1 over negative 2. So y equals negative 1/2. Isn't that awesome? Now, to be honest, I think a lot of folks would rather look at it as negative 0.5. And I think you could make the case that y could be either version because it does translate into a decimal really easily. You could use either one. When we're checking, I'm going to show you why both are actually very helpful. So we substituted in right there. Ta-da! We solve for y. Now we got to find the other one. Oh boy, isn't this fun? Aren't you glad I'm doing an extra hard one? Yay! Okay, so we're going to find x. We know that y is negative 1/2 or negative 0.5. Now, there's a lot on this page. But I would remind you that the system that we're solving is this one. And I'm going to tell you that as long as all you did was clear fractions or clear decimals, you move some terms around perhaps, if that's all you did, then this system will have the same answer this system will have. So I'm going to keep using this system. So I've got the 2 equations, x minus y equals 3, and x equals 2 minus y. There we go. So if I want to find x, I'm going to use this equation. So x equals 2 minus a negative 1/2, or you might have it as x equals 2 minus a negative 0.5. Your choice. In this case, we get x equals 2 plus 1/2. And right here, I've got x equals 2 plus 0.5. Now, this one is admittedly easier. X equals 2.5. This one is a little bit messier because it's either 2.5 or you have to convert it into an improper fraction. Remember, 2 times 2 is 4. And then you do 4 plus 1 equals 5. So we get x equals 5 halves. If you're not sure how to convert from a mixed number to an improper fraction, definitely check in with me. Check in with the tutors, or maybe even check in with Matt Damon. It's like his eyes follow you no matter where you are in the room. Okay, so Matt Damon is happy or sad? And the answer is, we found a y, we found an x, there is a single solution, we're in x land. It means that there is a solution right where the two lines intersect. So we do have happy Matt Damon. Yay! Happy Matt Damon. He's going home. Okay. Now, why do we have slightly sad Matt Damon too? Oh, sad Matt Damon. Well, Matt Damon realizes that at the end of it, we either get x equals 5 halves, y equals negative 1 half, or x equals 2.5, y equals negative 0.5, and that's fine, but the problem specifically said we need to check. Now, what does checking do? Checking allows you to literally check to see if you made a mistake. Is it possible to get the check wrong? Absolutely. So sometimes does a check go funny? Yes, it absolutely does. But in a perfect world, a check allows you to catch if you've made any little mistakes that you hadn't seen. And so checking is a really important step. But there is a catch. You always check the original. And what is the big sigh? Well, the big sigh is that the original equations were these two. And that's where maybe we're going to end up with a 400-minute video. Let's hope not. So let's go to the check. Now, in terms of taking a math class, frequently the check isn't worth that many points. You should always check. You should ask, like, how much is the check worth? Because it may be that if you're taking a test and you're short on time, you may choose to skip the check to do other things, right? There may be better uses of your time. In the real world, I do encourage you to check because it is a way to make sure that you're not going to crash Matt Damon into Pluto accidentally, because that would be sad, right? Although Pluto would probably not mind the attention. But I don't know, feelings are a little bit sore about the whole thing. So I would encourage you not to crash land Matt Damon on Pluto. I would encourage you to actually go to some lengths to figure out if the numbers you figured out were correct. Because I would suggest that I don't think anyone could look at, well, maybe someone can, but I don't think a lot of people could look at these answers, and remember there's the fraction form and then the decimal form, and be able to say that definitively it's a good answer. So let's go ahead and check. To check A, 2/9 x minus 2/9 y equals 2/3, I'm going to go ahead and use the fractions because it's already in fraction, right? So easiest thing in the world is to write the fractions in. So I've got 2/9 times 5 halves minus 2/9 times negative 1 half. Does that equal 2/3? So let's go through and see. The 2's cancel. And here the 2's cancel. So then I get 5/9. And then I see I've got a minus, so that's plus 1/9, right? So that's equal to 6/9, which is, if I reduce, 2/3. Aha! It worked! Okay, let's try the second equation. So the second equation, this one, 0.1x equals 0.2 minus 0.1y. And for this one, I'm going to go ahead and use the decimals because they're going to be much easier since this is written in decimal. So I've got 0.1 times 2.5. Does that equal 0.2 minus 0.1 times negative 0.5? You may need to use a calculator depending on how comfortable you are with multiplying decimals. 1/10 of 2.5 is 0.25. Double check this on a calculator. And I want to know whether this is equal to 0.2 plus, see the plus, the minus, a minus, and then 1/10 of 0.5 is 0.05. And again, you may need to use a calculator, but these two added together will in fact give you 0.25. Oh my goodness, they checked! Yay! Happy dance while I get out the happy Matt Damon. Yay! Matt Damon's so happy. Happy, 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 happy. So, that's it. That's how you use substitution. Woohoo! Congratulations. Blue Dinosaur is very proud of you. So is Matt Damon, but he's off celebrating, not crashing into Pluto. So in the next video, we're going to talk about another technique, which I actually think is, for the most part, going to be a lot better for you to use. And it's the one that we're going to be able to teach computers how to use. So that's going to be very exciting. So until then, take a deep breath. Try not to get your various devices in your house all excited about math, because they get very loud about it. Go out, get some green, get some fresh air, get something to drink, rest, relax, know that you're awesome, and come on back and we'll deal with elimination. Woo-hoo.